Hey everybody, welcome to my next video on Codesys programming. Appreciate you coming back. And again, as always, if you could, at the end of the video, if you find this useful, just like it and or share it if you could. Anyways, let's go on. This video is going to be covering math and comparison instructions. So you'll see up at the top here are the math operators that we have. We have some add, subtract, multiply, divide, and we have the comparison instructions, the equal, not equal, and so on, and how they work. Okay, let's just dive in. So the first thing I want to show you is I'm going to use this as a tool for when we finally get to the comparison instructions. Is this free running timer? I like to use these free running timers. I use this in all different PLCs that I'm involved in, and in this particular case, I've got it set to the PT is going to be set to 10 seconds, and what's going to happen is this timer is basically going to ramp up to 10 seconds, and then it's going to reset itself. Notice I'm using the Q at the front end of the timer. See that? I'm using the Q at the front end of the timer. That's actually the not of that Q is going to be what's going to give us the ability to reset it. So let me just show you that first, and then we'll move on to our math and our comparison instructions. So I'm going to log in, and I'm going to download, say OK, no changes, and it's in run. So you can see it's actually cycling right now. See how it's cycling? It's going to go up to 10 seconds and it will reset itself. Now, if you had things off the queue or a light or something that you had, let's say you had a set and reset instruction, set instruction, you'd see it turn on, or you had some other ladder logic, you'd see it trigger. But it's going to trigger for one scan and then it's going to turn off, right? Okay, so the next thing I want to go over is let's start and dive into our math instructions. So forget the timer for a second. We're not going to necessarily use it for our math instructions. We're going to use it for the comparison. Add, subtract, multiply, divide. There are standard math instructions. So let me just drop one down and put it below. And I'm going to put a add instruction, a 2-input add instruction. You'll notice that it has a contact. The default is to put a contact on the enable. I'm not going to use it in this example. I just want the add instruction to work. I'm going to put 2 tags, so my tag 1 in front, and I'm going to make that a dint instead of an integer, and then say my tag 2, and the output of it is going to be my tag 3, my tag 3. So I'm just making some basic tags, some basic symbols, and we're going to use it just to test this out. Let's online and multiple download. Yes. And close. Online's changed, and actually go log in. All right, so what do we got? So I got an add instruction. I'm going to write in my tag, I'm going to go write a value into it. So let's put a value of 10 in. All right, you'll notice, let's put a value of 5 in my tag 2. So it's going to add the two numbers together when I write all the values, and the result is 15. Makes sense, right? Standard add instruction. Pretty straightforward, easy peasy with just one simple instruction. But where it gets a little complicated is if we start doing formulas inside ladder logic. And this is where I'm not a big fan necessarily of these individual blocks ganging them together, although we can do that. So let me actually show you how that works. So I'm going to log out, for example, and this is going to give you it should give you an idea of why it gets a little cumbersome in ladder logic. So imagine I then want to multiply this value by another value. I have to use my tag 3, and let's say I multiply it by some value. I'm going to just literally put in a fixed number instead of putting a tag this time. Say my tag 3 times 10, and put that to my tag 4. Again, make sure it's a dent. Okay. Online login, download, and run. Okay, so again, if I go and add, I'm going to say 10, to that, and 5 to this. And then I'm going to write the values. You'll see it comes across. My tag 3 is 15, and then my tag 3 times 10 is 150. Yep, makes sense, right? But as you can see, it starts to get a little cumbersome, because what you end up with is you end up with instruction after instruction after instruction, and it gets a little difficult to see the formula. So in my opinion, if you're going to be doing a formula of any type, more than one or two calculations, iterations, you want to actually use structured text. And there's a great block that Codesys has that that works great for that. I'm going to show you it at the end of this video. Okay, that's just your basic math. Last thing I'll talk about in the math world is something you want to make sure you pay attention to is your data types. Of course, when I made my tag 4, I made all the tags dints. See that? Now, if I'm just doing add, subtract, multiply, a dint is fine. Generally speaking, a dint is fine. But if you're actually starting to do any divisions, you want to actually change your data types. You want the data type you want to use for your tags should be real. You want to pay attention to using real data types and as your data types. The reason is because if you don't use real when you divide, you're going to actually get a fractional component. You're going to get a loss of resolution. Of course, a dint, an int, a cent, any type of integer is what's referred to as a whole number, which means it doesn't have a fractional component to it. And when we divide, you will create, in most cases, a fractional component, like a decimal point after to the right of the decimal point, right? A remainder after the decimal point. So you want to pay attention to this when you're doing division. If you're doing division, you want to make sure you do everything as real. And we're going to see that in a little bit as a result of, we're going to see it when I do a scaled. I'm going to show an example of scaling, scaling using math. Okay, so anyways, from there, let's move on. Online login. I haven't shown you this actually. Have I shown you this? Yes, I did show you that 150. So let's go offline and let's go back and as a matter of fact, let's talk about the block that's going to give us the ability to do multiple instructions. I like this block. So I'm going to delete my add, subtract, multiply, and instead I'm going to add what's called an execute block. Now, for anybody that's used to Allen Bradley's Rockwell Automation, you'll know they have a compute and actually a comparison block. Well, this execute block allows you to do something basically the same as the compute or the comparison block. As a matter of fact, it's even more powerful than that, because it's not just a formula you're putting in there. What you're actually putting in there is structured text code. This block will execute structured text. So you can use it in this format or anytime you just want to issue structured text. Okay, so to do that, let me double click in and start creating my structured text. So for example, let's say my tag 1, actually my tag 4, let's say my tag 4 is equal to my tag 1 plus my tag 2. Okay, let's just leave it at that. Just leave some basic math and just see how this works. All right. So you need to learn the structure of structured text, the different format and operators and so on. So for example, when I want to say my tag is equal to this result, that's the format that you use. You don't just use an equal sign. You have to actually use a colon equals. That's actually pretty standard programming practice in most other programming environments. And then on top of it, you have to basically say where the end of your code is on each line by putting a semicolon. Okay, so that's what I've done there, and that's completed that block for me. Let's actually go put some values on these tags. So my tag 1, I'm going to actually put a default value up here. So equals 10. And I'll say my tag 2 is equal to 5. That's going to give me some value that we're going to see when we actually run this. So online login, download, you'll see the execute block will run. Once I've downloaded and I push play, you'll see the execute block should actually run. So we have tag 1 is 10, tag 2 is 5, and my tag 4 equals 15. It does the operation. But the point is that we see the formula here. We see the formula, and we don't have to worry about the we do not have to worry about the intermediate values between each block. And on top of it, we actually don't have to worry about something called bed mass. So we don't have to deal with bed mass. We don't have to really worry about that, because just by the nature of how we write our formula in the structured text block, that is actually going to do create bed mass. It's going to create that order of operation for us. Okay. Okay. So here's an interesting one I'd like to throw at you is what I want to create now is I want to envision for a second that we have here's a real useful thing that we can use this execute block for. So imagine for a second we actually have a 4 to 20 mil signal coming in. Whatever it is, we have a signal coming in that's 4 to 20 mil. It's a raw input that's going to be scaled, or it's going to come in as 4 to 20. And what we want to do is we want to actually scale that to an engineered value of, let's say, 0 to 100. So I'm going to show you the formula. I'm going to quickly put it down here and just show you how this raw block will work for us. And this is a pretty powerful tool. I believe this is a pretty powerful tool in the end. So let me try this. So I'm going to delete that, and let's delete some of these. Just clean this up. I'm going to leave my timer in there. We're going to use it for the comparison block in a second. The tags that we want to use, I'm going to call them in raw. That's the first ones. Sorry, in raw. And I'm going to make it a real. Sorry. Actually, I'm going to make it a real at this point. And I'm going to put a value. I'm not going to put a value into it. I'm just going to leave it as a value of 0. So, I'm going to be able to write to it. As a matter of fact, is what I'm going to do in raw. So in max colon real, and I'm going to give this a value. So I'm going to have my input max, my input minimum, my output max, my output minimum. So this is a pretty standard engineering formula for scaling your value, and we're going to put the fixed values in here and create our execute block and see how this works. So I'm going to say input maximum is equal to 20, and enter with the semicolon, and I'm going to say input min is equal to, our input min is a real, and it's equal to 4 is my minimum. Output max, I want to scale my 4 to 20 milliamp signal. I'm going to scale it to 0 to 100. So we'll say real as well, and colon, and I'm going to say, sorry, equal to 0. The max is 100, and output min is equal to real. I'm going to make it a real, and I'm going to equal to 0. And then I'm going to put another one called scaled out, and I'm going to make that a real as well. Again, you want to make sure all your data types match, right? Notice that they're going to match, but the other thing is you're going to notice that I'm using real here because I'm going to be doing a division in this execute block in a second. The other thing is, you know what? I just because I want to actually make the format correct this format so that they're the same. Just because I like to see it like that, and say OK. That should be good. Now from there, I'm going to go and create my network, and I'm going to drop down one of these execute blocks. Again, I just want it to execute, so I'm going to get rid of the enable and go in and start typing. So the pretty standard formula, I'm going to type this out for you so you see what it is. Pretty standard formula. Scaled out is going to equal, and I'm just typing it in from my camera. Actually, I've got it typed in somewhere else. So in raw, subtract in min times out max, subtract out min. There's our divide. So this is what you want to be careful of. Input max, subtract input min, double bracket output min. And semicolon. Enter. Okay, so what I want you to see here is a couple things. You want to be very careful. Some of the mistakes people make, they forget, first of all, they forget they have to do an equal like that. That's the first thing. And so you got to say scaled output. Your physical output is equal to, and here's the formula, right? So there's our formula. And of course, the other thing they forget to do is they don't keep track of the brackets. You really have to pay attention to the brackets, right? So you can see here I've got double brackets and inner brackets, and a double bracket going out. So you want to pay attention to those brackets and make sure that you maintain them. Of course, the system will put a red line under it if there's a problem, if it sees a problem, but that's good. I've typed it in from my phone, actually, where I had an example of it that I had taken a picture of. So I just wanted to type it in and show you. But as you can see there, that's something you can see. It's a formula. It's a physical formula that's doing something for you. Okay, it's a lot easier. Imagine doing this in multiple ladder logic instructions, all the instructions that you'd have to use. You'd never see this formula. The formula just wouldn't make sense to you. All right, so it really is more a little more structured here in this structured text. Haha. Okay, let me try this out. Online login with download again. Let's try this out. And 4 to 20 mil. And as a matter of fact, what I forgot, I want to log back out. I want to actually put something in, just a tool that I use. I use a lot just to give me access to tags. Just an easy way to access tags, I find anyways. So a lot of times I'll just put a move block down. So a move block, there's the instruction there. I'll just, when I'm testing hardware, or testing code, I'll put a move block down and I'll move data to itself so that it gives me something to write to in the logic. In the case of our execute block, we don't necessarily have access to the tags, so I'm going to use a move block to give me that access to my raw input. So in raw, and I'm going to write in raw to in raw. Again, a move block, we haven't seen that yet. It's a way of moving data from one location to the other. It's just moving one piece of data from one spot to the next spot. But in this case, I'm just moving it back into itself. But it's giving me access to input raw. So let me go and do this. Download and run. Okay, so imagine for a second we have 4 milliamps. So I'm going to put 4 milliamps in here. 4, and I'm going to write that, and you'll see the output is still, the scaled output is at 0. See that? But let's try this at 20. We should see it go to 100 if I did that correctly, if the formula is right. So you can see it's scaled to 100 now. See that? I put a value of 4. My input, my maximum input was 20, and my output is now 100, so 100%. So the real test of this would be the halfway mark. halfway between 4 to 20 is actually 12. So let me go and put a value of 12 in here and see what happens. Write the value, and we see 50 as our spot. So seems to work great. Okay, that's a scaled standard 4 to 20 scaling. You could use that for anything. Temperature, you could use it for whatever you want, right? You could scale any value coming in. There is no in the core Codesys blocks, there's no core scaling block. There is one that allows you to do what's called a linear transform, but yeah, it's not in the basic instructions. So this is a way of doing this yourself if you want to. Now, before we go too far out of the math, let me actually log out. I want to show you the result, what happens if you do not use the right data type. So I'm not going to change my values here, but what I'm going to do is I'm going to change the data types to dint. I'll change each one of them here to dint. And then I'm going to download it, and I want to show you the difference of what happens here. Dint. Because we are actually dividing, right? Dint. And I'll change this to dint, so my output, and let's download it and try it. I downloaded and tried it, and here we go. So I'm gonna go and put input raw. Again, I'm using my move block here. I'm gonna say it's 4. So at 4, we should have 0. If all's well, we should have 0. So yeah, scale output is definitely at 0. Let's try it at 100 now. Let's see, which is 20 milliamps coming in. What happens when we actually use a dint? Look at the value. The value is actually 96. There's a resolution loss of 4 points, 4 ticks, however you want to call it, 4 digits. All right, 4 degrees. So that, that's significant. 96 degrees could be a significant difference between 100 degrees. I don't know, but yeah, it's a difference. There's quite a bit of a difference here, right? So you want to be careful of that. So that's why you would want to do this all in real, because we have a division happening. Okay, so that's my execute block as a scale, using it as a scale. Let's actually go and do a comparison. Let's try comparison blocks now. I'm going to delete this stuff that I've done now, and I'm going to go back to using a comparison block. So using the comparison block, what we're going to see is we've got a bunch of comparison blocks we can use: the equal, not equal, less than equal, greater than equal. We've got a bunch of blocks that are available to us. We also have, as a matter of fact, have something called a limit block, or we are going to be able to use our execute block. We're going to see that as well. And for this, I'm going to use my free running timer that I was talking about before. I'm going to actually use the elapsed time of this timer to represent something that's moving. So it's going 0 to 10. We can use that to represent, let's say, a tank filling or something like that. So anyways, let's, for example, say that we wanted to turn a light on when the tank was half filled. So let's right click, put in insert a network below, and I'm going to put in a greater than instruction. Again, we're not going to use the enable, and we're going to use the ET. And when it's greater than, let's say, 5 seconds, I'm going to go and actually turn a light on. Let's turn on light 3. It's going to make light 3 for me as a Boolean, and good to go. Let's try this out. Log in. I'm going to actually, I downloaded. I'm going to download anyways again and push play. Nothing changed, and push play, and we're good. So you'll see when it's above 5 seconds, it turns the light on, and of course our timer's resetting, so it goes from 0 again. So you can see the lights turned off. So that's great. we can do comparison greater than equal to, or whatever. The one you want to be a little careful with, I've been caught with this myself, is the equal instruction, is using that on such a finite move, or a small move that we see in the timer. The timer is only good for, it's doing 1 millisecond intervals, so an equal will only be equal for 1 millisecond, so you want to be careful of that. But the next thing we could do, if we think about it, we could start ganging these together in an and and an or type fashion. So for example, what we could do is, what if we wanted to say, what if we wanted to turn on a light when it's within a range? So it's greater than some lower limit, but less than a higher limit. So I'm going to actually gang these together. So when the timer ET is less than, let's say it's less than, let's do 2 seconds and 7 seconds. Number sign greater than 2 seconds and less than number sign 7 seconds, less than 7. So within that range, it's going to actually turn on a green light for me. So online, log in, download, say OK, and push play, and we should see it turn on when it's in between. So it's 2, it's on, see that? And then when at 7, it'll turn off. So it's within the range. If you wanted something that was outside of that range, you could do an or statement if you want. You could take these two instructions and do an or. So put a branch down and then bring the less than and greater than in an or type fashion. When it's less than a certain amount but greater than another amount is what you could say, turn a light on. That would give you outside of the range if you wanted to. Or you could just take the not of light 3. So I could actually just say, you know what if I wanted to do a red light? What if this was a green light? Green light. We'll say okay. And what if then we also wanted to turn a red light when it's outside of the range? So network below. This is probably one of the easier ways to do it. Just contact. Sorry, I negated contact. And we would do a coil. So a red light. Say okay. And when it's not green, turn on the red light. So let's try that out. That'll give us outside of that range, right? So it's inside the range, so 3, 4, 5, 6, 7, and then it's outside the range. Okay. Now again, in the Rockwell world, we see in the Rockwell world they actually have the compute instruction, which allows you to do structured text, or they actually have the comparison instruction, and that allows you, well, they don't allow you to do structured text, but they allow you to do formulas or expressions as they're called in the Rockwell world. But here in Codesys, the execute block, as we know, we just saw with the math instructions, it allows you to do structured text. So I'm going to drop this down, and let's do the same thing here in a formula in structured text. So actually, I'm just going to do the one function. So when it's, I'll just do the one function when it's above 2 or above 5. When it's above 5, we're going to turn a light on. So I want to do the same thing as this. Okay. All right. So let me just fix this. 5 seconds. Good to go. So I want to do the exact same thing. All right. Is this greater than? Okay, so I'm going to actually use structured text programming if ton underscore 0 underscore et is greater than, let's say 5 t number sign seconds, then So this is an if-then statement. Then turn on green. I'm going to turn on light 3, so I don't want multiple things turning affecting a light. So I'm not going to drive green light. So light 3 equal. Make sure light 3 is equal to true. There. There's also else if. Else. So if then else statement. This is a pretty standard programming statement in a structured text world. So what we can say is light 3, if it's not on, if it's not greater than 5 seconds, then turn off light 3. That's what we want to do, right? So equals false and hit. Okay, so that's going to turn on and off light 3 for us. All right, let me delete this. And let's actually see this work. So online log in with download, and push play. And what we're going to want to look at is light 3. Light 3 should actually turn on. And you can see that there when it's above 5. You know what? We could have used that actually down below. We could have even done one more step and actually used, which you're probably going to do. You're going to use light 3 somewhere else. Light 3 to turn on light, let's say another light, completely new light, light 4. And this will show it right in the ladder logic for us. Log in with download, okay. Push play, and we should see this turn on. Okay, well, why would you use the execute in this example? Why don't you just use a greater than instruction? Absolutely, that's a great statement. Why don't you just use a greater than instruction? But the real catch is when you want to actually start doing math inside there and do formulas. So if you want to do this comparison and a formula at the same time, you would want to use this execute block. So you can do more than just what I've done here in this structured text. You can add to it, and you have the full complement of the structured text language that you can actually use. Okay, that's it for this video. And again, if you found it useful, please do me a favor and like the video for me, and hope to see you on the next video. Thanks, bye.